All right. So now we're going to talk about parallel lines and transversals. So the big idea here is that we already looked at how to investigate different angles at the same intersection. So for example, if two lines cross and there's a 10-degree angle, we can automatically go, oh, well, this is a linear pair. We got the rest of it, which is 170. Oh, we have vertical angles, which are congruent. This is 10. We got vertical angles is 170. So once we know a single angle, we know everything there is to know about that intersection of two lines. Really today, the big idea is now we're looking at the relationship at different intersections, okay? How is this intersection related to this intersection? Can we talk about a specific angle at the two intersections and how they relate to one another? That's the big idea, okay? So keep that in mind as we go forward with a lot of vocabulary. This video is really about naming different angle pairs at different relations or different intersections. Okay, so just to review here, we've got parallel lines that have to be coplanar. So these are two lines that never intersect, and the thing we forget are, now that we're talking about 3D possible space, they have to be coplanar, right? Because in that green picture there, those two lines don't intersect, but they're not parallel, right? So you need them to lie on the same plane and be parallel. And any two parallel lines in space, even if you're like, well, what if I threw one up here and one down there in 3D space? You can create a plane that goes through them. So they're considered coplanar because there exists a plane. It doesn't have to be shown in the picture, right? Okay, the symbol in writing are these two vertical parallel lines. So that means line AB is parallel to line CD, okay? In an image, what we do is just like we use tick marks. So if we have two line segments that are congruent, we put one tick mark, or if there's then in the same diagram we have two other line segments, we can say, oh, well, these two are the same with two tick marks on them. We do the same thing with parallel lines, except we put arrowheads in the middle of lines. So if it's an arrowhead, so two arrowheads match with two, means these two lines are parallel. Or, you know, I could have another set of lines over here and go one in the middle, one in the middle. And those arrowheads in the middle of the same number tell you which lines in the picture are parallel. Okay, so I'm just reviewing the vocabulary, but maybe establishing some new symbols and some new language we'll use around it, right? So parallel planes. So parallel, the word parallel can also apply to planes, not just lines. It looks like this. Again, it's kind of like if you imagine a book, a closed book, and you have page 5 and page 100, right? Those two won't touch, right? But they're parallel planes, okay? And then perpendicular lines, they're two lines that intersect to form a right angle, or depending on the book, sometimes they'll say form to meet a 90-degree angle. Okay, the symbol for perpendicular we've already been using, but it's that symbol right there. In an image, we show it with a little square at the intersection. Okay, last thing is skew. And again, these are all things we've already talked about in past videos. So skew lines are that example I showed you before. So these are two lines that don't intersect, but they are specifically not coplanar, right? If a plane exists that goes through them, they are either parallel or they are intersecting, right? Those are the only two possibilities if they're coplanar. But if they're not coplanar, then they don't intersect, okay? So two lines that never intersect and are not coplanar, all right? And that picture kind of shows you what's going on, okay? Now, this is a time you could jump onto IXL. I'll do 2 IXLs at the end of the video just to do some quick practice with you. Okay, so new, transversal. This is a new vocabulary word. It's a line that intersects 2 or more other lines. So it could intersect 3, it could intersect 4. Transverse is really means to go across or to cut. And so we say that 2 lines are cut by a transversal, kind of in like a question, or 2 lines are intersected by a transversal. You'll see those sentence structures in the geometry textbook, or I'll speak them out loud. And the 2 lines, note, do not have to be parallel. So notice in my picture, I have 2 green lines here on the left that are definitely not looking parallel, but still the line that passes through both, 1, 2, that one line hits both, it's a transversal. Notice that too, if I did 3 lines looking like this, and I labeled them like A, B, and C, well, every single one of those 3 is a transversal of the other two, right? So A is a transversal of lines B and C because it hits B and C. So A passes through two or more lines. So A is a transversal of lines B and C. B is a transversal of lines C and D because B crosses here and here, right? So it crosses A and C. So just the lines don't have to be parallel is the biggest assumption that students actually make is, oh, I see transversal, I hear vocabulary around transversal, so I assume the lines are parallel. Do not make that assumption, okay? We use the vocabulary whether or not things are parallel. And over here on the right, I just showed you can have a transversal crossing 3, 4, 5 lines too. Okay, now, when a transversal cuts two lines, we're going to create some vocabulary talking about these angles. Again, we are not talking about angles at one intersection, right? We already have vocabulary for that. Linear pairs and vertical angles. That's the relationships at one intersection. We're saying, what if I picked one of these? How does it relate to one of these down at the bottom? What's the relationship between angle 2 and 6? Or 2 and 5? Or 2 and 8? Or 2 and 7? And those are the relationships we're going to discuss right now. Okay? So we're going to come up with some names. Well, the first one is corresponding. This is the most logical. Okay? Corresponding angles. And again, this is talking about when a transversal cuts two or more lines. Corresponding angles simply means they're in the same analogous location. Right? So my right arm corresponds to every other human's right arm. We all have different right arms, different hairs on it. Maybe I have a scar on my wrist from when I got cut by poison oak and it just never healed. I mean, we all have different right arms, but they're all analogous, right? My right arm's even analogous. It's even corresponding to like a dog's front right leg, right? So it's just saying, yes, I know this intersection at top is different than this intersection at bottom, but this B in the top right corresponds to this B in the top right down here, okay? So those are corresponding angles. They're in the same analogous location, okay? Again, lines do not have to be parallel just because we call them corresponding angles. I purposely tried to draw these two lines not parallel, but we still call those corresponding angles. So if I drew a picture here, and I could even make that totally not parallel, I could do like, it looks like this. And then I cut it with a transversal here, and I go, okay, angle 1, 2, 3, and 4, which one corresponds with angle A, right? Well, the corresponding angle to angle A is angle 3. Okay, the lines don't have to be parallel. We still say angle A and angle 3 are corresponding. Okay, and then here's what we're going to get to in the next video. I drop it in here. But in the next video, we're really going to look at proofs and postulates and theorems using these relationships. But the big idea here, and that's going to be our first postulate in the next video, is if the two lines are parallel, then a line cutting through them both, however it cuts this angle, right? Whatever angle that is, let's say it's 20 degrees, well, this line is going in the same direction as this line. And obviously, this transversal is going in the same direction as itself because it's a straight line. So same direction and same direction with same direction and same direction. It has to logically make the same angle. Like it's literally the two lines are going in the same direction. So this has to be a 20-degree angle. So if the lines are parallel, then corresponding angles are congruent. However, again, we still use the vocabulary corresponding angles even when two lines are not parallel. This would still be corresponding, A and B would still be corresponding angles, even though the lines aren't parallel. All right, alternate interior angles. So alternate just means opposite sides of the transversal. So here this pink line is the transversal, okay? So two angles, again, I'm talking about an angle from the top intersection paired with one from the bottom. So alternate angles means one's on the left side and one's on the right side. Okay, so we got two angles, one on the left, one on the right. But they're both interior angles, which means they're in between the two lines. So the only way we could satisfy that is if I pick this angle, well, I'm going to the other intersection, so somewhere down here, that is inside the two lines, so it's either option 1 or option 2 here, the only interior angles on the other intersection. And then alternate means the one on the other side. So it has to pair with this one. So alternate interior angles is this pink angle with this orange angle. I'm going to clean this up just a little bit to get rid of some of my notes. Okay. And then the two blue angles also. They're in between the lines at different intersections and on opposite sides of the transversal. I know I use a lot of words there. This will become second nature as you start to use it more and more often. It's new vocabulary. Yes, you need to incorporate that into your lexicon. You need to remember it. But the idea here is alternate interior angles are interior. Whoa, I used an eraser there, not a pen. So they're interior between the two lines, but they're on opposite sides. Okay? Same thing for alternate exterior, except so they're on opposite sides, but they're outside the line. So now we're talking about this angle paired with outside the lines, but on the other side of the transversal. So here's the alternate interior angle, or exterior. I used the wrong word. Okay, so we've got pairs of alternate interior angles. We've got pairs of alternate exterior angles. Again, the blues match also. Those are alternate exterior angles. And then the two reminders, lines do not have to be parallel to use these vocabulary words. Okay, we still call them, right? The lines over here do not at all appear to be parallel. They're not marked as parallel. We still use the words opposite interior angles. But if the lines are parallel, then yes, the alternate interior angles are the same and the alternate exterior angles are the same. And we'll do this proof in the next video, but it's so easy, right? If we make the one assumption that corresponding angles are congruent when lines are parallel, so we go, if lines parallel, then corresponding angles are congruent, well, then we simply take one step and go, but this one matches this one because they're vertical angles. And so these are the same, and these are the same. So these two are the same by transitive or substitution, right? So that's the idea of why the alternate interior, and then same thing for alternate exterior. We just do vertical angle here, and now this one matches this one. So it's a very short, direct proof once we make the corresponding angles assumption. That'll be the postulate we all agree on. So we don't need lines or parallel to use the vocabulary. But if the lines are parallel, then what we know now is, so if these lines are parallel, then this angle is the same as its corresponding and the same as its vertical angle. So all of these angles match, right? And similarly, these angles must match then too, just by subtraction from 180 or by using the same logic. So that's the big idea here. Is if the lines are parallel, look at what we've got. We've only got two unique angles in the entire picture, and we got 4 copies of them. So this whole top intersection is the same as this whole bottom intersection if the lines are parallel. Okay, last vocabulary word, and this one will be helpful when we get, especially when we get to quadrilaterals and investigating like rectangles, squares, parallelograms, etc. So consecutive interior angles, consecutive means they're on the same side, and some books actually call it, they call it same side interior. And that's pretty common in other textbooks. Our book does consecutive, which means one after another. So like in a polygon, consecutive angles means like, I'm walking, there's an angle, and oh, there's its consecutive. So one right after the other. So that's the idea here. Consecutive interior angles means on the same side, and as I were to like walk a journey, I would hit this angle, and then I would hit this angle next. So that's what same side interior or consecutive interior angles mean. Okay, now again, lines don't have to be parallel to use vocabulary words here. But if the two lines are parallel, then consecutive interior angles are supplementary. And the reasoning is really easy, right? Like you're walking along a direction, you make 2 turns, and now you're walking in the same direction, but backwards. So you did an exact 180-degree turn, right? You were facing forward, and now you're facing exactly backwards, the opposite direction. So this angle plus this angle add up to 180 degrees of turn. So it makes sense. And again, we will prove this, and it will just be the same proof I just kind of mentioned before, but with linear pairs and 180 subtraction, okay? All right, so again, big picture here is if 2 lines are parallel, then these 2 intersections are the same, right? We already knew if we had 60 degrees, we could go, well, this is 60, this is 180 minus 60, and this is 120. The whole idea is if we come across that the lines are parallel, Well, then we know all of these numbers are the exact same down there because this line is going the same direction as itself. And these two lines being parallel are going in the same direction. So they intersect the line in the same direction. That's it. That's the whole big idea for this whole section. We use a lot of vocabulary to establish that, and we'll write proofs in the next section. But the whole idea here is if two parallel lines are hit by a transversal, the two intersections are the same. That's it. Okay, we're going to do a bunch of homework questions of vocab. I went ahead here and put the book's chart of just some examples, like here's a picture, which ones are consecutive interior, which ones are on alternate interior. But now I'm just going to do a ton of examples. So the video is 15 minutes in terms of lesson. Now it's going to be who knows how many more minutes of just examples. Okay, so find the error. Juanita and Eric are naming alternate interior angles in the figure at right. One of the angles must be angle 4. One of the angles must be angle 4. Interesting. Okay, so let's say angle 4 here. Let's say these are our two lines, okay? And this is the transversal that cuts across them. Well, the alternate interior angle here is angle 9. Okay, so 4 and 9. Check. Okay? Eric said 4 and 10. What would be the relationship between angle 4 and 10, name-wise? I just pause there for effect. You could literally pause the video. But these would be called same side interior. Oh, not this book. These would be called consecutive interior in this book. Okay. And then let's look at 4 and 6. So 4 and 6, he's just shifting his perspective. And he's saying, well, what if we're looking at 4, but now we have, let's look at these two lines as our two lines, and this being our transversal that crosses them. Well, then its alternate interior angle is 6. Okay, so 4 and 6 work. Again, 4 and 5, that would be consecutive interior. So Eric's issue here is he's mistaking the concept of alternate sides with the idea of same side. And so he's naming consecutive interior or same side interior rather than alternate interior angles, okay? And so Juanito is right here. Okay. Identify the pair of lines to which each given line is a transversal. Ooh, that's good. Okay. So P is a transversal of, so let's see. So P, identify the pairs of lines to which each given line is a transversal. So now this is a weird one. Start with P. Okay. So I would say shown in the diagram, none. But since these lines aren't parallel, I mean, this line will extend and P will hit it somewhere. So you could also, like, if these lines aren't parallel, you could really pick any two and it's a transversal. So it's not shown to be any, but you could definitely say P crosses T and then it will cross R. So you could say T and R. Right? So either one of those answers might be good there. Okay, so Q. Well, Q definitely crosses R and then it crosses T. So this would be R and T. And then R definitely crosses, I'll use a different color here, or I'll just erase it. So R definitely crosses Q and then definitely crosses T. So you could say it crosses Q and T. T definitely crosses, oh man, T crosses all three. Just in the picture, it goes 1, 2, 3. So that would be P, Q, and R. Okay, identify which, or identify each pair of angles as alternate interior, exterior. Got it. Okay, 7 and 10. Okay, so 7 and 10. All right, well, this is the one transversal that hits the intersection and goes to the other intersection. That means the other lines that transversal is crossing is this line and this line. So we have two angles in between them, but on opposite sides. So those are alternate interior angles. Okay, now let's erase that and do some new ones. So we've got 1 and 5. So 1 and 5, 1's here, 5's here. So again, these are on the intersections of this line. So it's the transversal. And then it hits these other two lines here and here, and they're both in the like top right position, right? They're both on the same side of the line, but like, you know, they're not exterior, they're not interior. They're both analogously on the same side of that line. So that's exactly corresponding angles. Okay, 4 and 6, I'm going to start speeding up a little bit here. So 4 and 6 are along this line, so it's the transversal. They're both in between these two lines, and yet they're on the same side, so this is consecutive interior angles. 8 and 1, I'll switch color here to maybe orange. So 8 and 1, they're along these two intersections, so that's the transversal. And now between these two lines, they're both on the outside and they're on opposite sides, so that's alternate exterior angles. Okay, name the transversal that forms each pair of angles. So that forms 3 and 10. So passing through 3 and passing through 10, the one transversal is line P. The one going from 2 to 12, so going from 2 to 12, that's the exact same transversal, right? Name the transversal, then identify. Gotcha. So it's still P for the second one. So 3 and 10, those are both in between the two lines and same side. So that's consecutive interior angles. 2 and 12 are, I'm going to erase some of this. So that same transversal. But now 2 and 12 are outside of the two lines, but on opposite sides. So that's alternate exterior angles. And then 8 and 14. So 8 and 14, that's this transversal here. And so those are both in between the two lines, but on opposite sides. So those are alternate interior angles along the transversal Q. Okay. Now, identify each as alternate. So this is the same as above. So I won't do them all, just kind of hop around, and we'll do them a little quicker. So 2 and 10 are corresponding along transversal J. So this is corresponding. 5 and 3 are alternate interior with these two lines, and this being the transversal. So this is alt int. I'm going to erase some of that. Let's see, 5 and 15. So 5 and 15, here's the transversal. They're alternate exterior. 8 and 3, so 8 and 3, here's the transversal. They're same side or consecutive interior. 1 and 11, so 1 and 11, that's alternate exterior. 6 and 14, let's look, 6 and 14, those are corresponding along this transversal, with these two being the lines. Okay, 11 and 13, that's this one and this one, alternate interior. And then 9 and 4, those are consecutive interior. I always want to say same side. Makes more sense to me. Okay, we'll just do a couple more at the end. Yeah. Okay, so identify each pair of angles. So same thing as before. Was there a second part to that question? Nope, that was it. So let's do a couple more. So 2 and 10, corresponding. These are different, right? They're not the same. Oh, that's the exact same problem. Ha, that's funny. Okay, guys, well then we'll stop there. I'm going to jump over to IXL and do a couple more examples. Okay, so first I'm jumping on D1, which is just identifying parallel, intersecting, and skew planes and lines. So in this one it says, in this rectangular prism, okay, we haven't talked about 3D objects, but just a box, which lines are intersecting? So first of all, if any have the same letter, like KO and OP, those meet at O, right? Those are the only ones that share the same letter, I think. So let's look at it. JK is here. Does that hit NO? No, those are parallel. IL and JK. So IL and JK are parallel. And then KL and JN. So KL and JN. This one, those are skew. So no, that's it. It's just those. Okay. Which lines are parallel? So select all of them. So we have IJ and DG. So IJ and DG, yeah, those two are parallel. FJ is this vertical one, and EI is a vertical one, yeah. HK and DG, HK and DG, yeah. And then HI and JK. So HI is across, and JK, wow, all of them, I like it. Okay. Which lines are parallel? We just did a question like that. I'm going to skip ahead to some different problems. Okay, which lines are intersect? What the heck? We just did a problem like that. But let's do it anyways. Okay, so the only way two lines could be intersecting is if they meet at the same point. So these both have an S in it. These both have an S in it. These both have a W in it. And QT and WX can't meet. So WX and QT, those are skew. So nope. Okay, which lines are skew? Oh, this is interesting at pyramid. So OR and PQ. So OR and PQR. This OR goes up and up and up and away, and this baseline back here, QP, never hits it. So that's skew. Let's see, these both have an R in it, so they intersect at R. They're not skew. NR and PQ. So N to R and P to Q, that's the same as the other one. Yeah, one's going up through the tip and keeps going, and one's a different base that they will never meet. PR and NO. So PR and NO, that one is also skew. Good. Okay, which planes are parallel? So the only two planes that are parallel is this top plane, TUS, with the bottom one, PQR. So TUS and PQR, and none other have that. So any other face they name, right? Any of the other side faces hit each other, and the bases hit the side. So there's no other parallel planes in this entire picture. Okay, in which lines are intersecting? So to intersect here, they have to share a point, because otherwise the lines would be skew if they don't, or they'd be parallel, like LO and MN. So let's check. No shared points. Those do not share a point. Hey, those share a point. Okay. Which lines are intersecting? Again, they have to share a letter here in these diagrams to really be intersecting. I think that's the only ones that share letters. Okay. Which lines are skew? So this is a more interesting question, because they could be parallel, they could be intersecting. So NR and LO. Actually, let's just move on to the next skill. That was some good practice, you guys. Let's move on D. We're going to now go to name the angle pairs, which is what we were just doing, but now we've got a harder to visualize maybe drawing here for us, okay? So which angles are corresponding angles, okay? So, and it doesn't even matter that they're parallel. We could still call them corresponding without being parallel. So we've got RQT. So the only angle it corresponds with is this one down here, VTU, and it's not that one, okay? RQT, again, it's not the UTV. This is the UTV. It's the only one that corresponds with RQT. Okay, and which ones are vertical angles? Now there's lots of options. So TSP is the first choice in all of these. So we got TSP. So the only vertical angle to this is USR RSU. Okay, RSU, there it is. Which ones are alternate interior? So again, they all start with POL. So let's start with POL. POL. And so the only one that's alternate interior with this one right here is KLO. That has to be. Or OLK, right? You could name the angle either way. Okay, let's do one last one together here. Supplementary. There's lots of possibilities. So HGJ. This is where now we start to use, so HGJ, there are a lot of supplementary things in here. So first off, if I just take out my drawing tool here, and I have this to start with, so just need to grab this. If this is the angle I start with, right? Well, then you have lots of supplementary angles. Just based on what we know from like chapter 1, these two are supplementary with that angle right away. But then using what we're going to develop in the next video, which is the idea of if the lines are parallel, then all the intersections at the bottom are the same. That also means that these two, which are the same as those stars up above, are also supplementary with the original angle. So I wonder which way they went with this video. Let's see. Or with this challenge. So EGH, is that an option? Nope. FGJ, there it is. That's the one. Boom. Okay, you guys, and the rest are kind of just similar to those. So I just wanted to show you what to expect on IXL. Hope you enjoyed the video.